back to the QST YouTube channel. Today I'll be explaining the past papers from section 4.1 to 4.4. So first of all, I'm going to be explaining paper 4 version 42, October-November 2024, question 2. Let's start. A block of mass 20 kilograms is held at rest at the top of a plane inclined at 30 degrees to the horizontal. The block is projected with speed 5 meters per second down a line of greatest slope of the plane. There is a resistance force acting along the block. As the block moves 2 meters down the plane from its point of projection, the work done against this resistance force is how much? 50 joules. Look, let's draw the free body diagram first. Here we have the angle 30. Here we have the block. This is the weight, normal. Okay. Here we will have W cosine 30. I'll just write W cosine 30. Here we have W sine 30. Then up we have the resistance force. Okay, so work is equal to force times distance, right? And also net work net, I'll just call it Wn, is equal to the change in kinetic energy, right? And what is kinetic energy? Kinetic energy is equal to half mv squared. So since work is force times distance, what is the force we're talking about in this case? W sine 30, right? So since we're gonna use G as 10 since they didn't specify, so 200 sine 30, that's the force, times the distance minus the resistance force, right? Since it's a resistance force, it's gonna go against the force, right? Okay, so minus 50 is equal to half mv final squared. So I just call it, I just simplify it. 20 times half is 10 v squared minus, right, 1 over 2 times 20 times 5 squared, which is 25. They said 5 meters per second here, so that should be 250. We're gonna plug this into the calculator. Once again, I'll say it. 200 sine 30 times 2 minus 50 is equal to 10 v squared minus 250, and that is going to give you 2 radical 10 or 6.32 on the calculator. I'm gonna be explaining paper 41 version 1, paper 4 version 1, October-November 2024, question 2. So a particle of mass 7.5 kilograms starting from rest at A slides down an inclined plane AB. The point B is 12.5 meters vertically below the level of A as shown in the diagram. Given that the plane is smooth, use an energy method to find the speed of the particle at B. Look, what I'm gonna do here is the conservation of energy. Of energy, that, or you could do conservation of mechanical energy actually, right? So here at point A, let's start writing the givens. Height is equal to 12.5, right? The velocity is 0. That's the problem. But at B, right, height is 0. And we need to find V here. So we can just do an expression to find the kinetic energy, right? We can just find an expression to find the speed, which in this case, right, as we said, kinetic energy is equal to half mv squared, and potential energy, like gravitational potential energy, is equal to mgh. Okay, so what we can do here is we can equate kinetic energy to gravitational potential energy, because there is no kinetic energy at point A and there is no gravitational potential energy at point B. So we can cancel the mass out. So G is 10 as always. 10 times 12.5 is equal to half v squared. Now let's plug this into the calculator. 125 is equal to half v squared, and you're going to get 5 radical 10 or 15.8. Part B, right, it is given that the plane is rough, so we cannot do conservation of mechanical energy. But there is, okay, it is given that the plane is rough and the particle reaches B with a speed of 8 meters per second. The plane is 25 meters long and the constant frictional force has a magnitude F Newton. Let me just draw the what's that called, plane again. Okay, so here we have 12.5, and what they mean by 25 meters long, that this part is 25, right? So what we are going to do here, there is a rule where change in mechanical energy is equal to the work of friction, right? Now look, the change in mechanical energy, as we said, it ends at here, at point B, where it's half times m times v squared. What we're doing here is final mechanical energy minus initial mechanical energy, right? As we said, the final has only kinetic energy, so half times 7.5 times what was it again? Times, they said v squared is, they said v is 8, so 8 squared minus mgh. M, which is 7.5 times 10, 7.5 times g, 75, times 12.5, right, is equal to the work of friction. Look, the work of friction, which is what we're trying to find, is the force F times the distance 25, which they gave, times cosine the angle. Since we said the direction of motion is downwards, positive, friction is opposing it, trying to make it go up, so it's going to be negative F times 25, right? So we plug this into the calculator. 1/2 times 7.5 times 8 squared minus 75 times 12.5 is equal to negative x times 25, which is going to give us 27.9 newtons. Where was it? F is equal to 27.9 newtons. Now I'm going to be explaining paper for version 2, October-November 2023, question 1. A block of mass 15 kilograms slides down a line of the greatest slope of an inclined plane. The top plane at a vertical of 1.6 meters above the level of the bottom plane. The speed of the block at the top of the plane is 2 meters per second. Question: a block of mass 15 kilograms slides down a line of the greatest slope of an inclined plane. The top of the plane is at a vertical height of 1.6 meters above the level of the bottom of the plane. The speed of the block at the top of the plane is 2 meters per second, and the speed of the block at the bottom of the plane is 4 meters per second. Find the work done against the resistance motion. So when they say resistance motion, right, work done against resistance motion, immediately friction. That's the first thing you think of, right? And then once you notice that you're trying to find friction, all you need to do is realize that change in mechanical energy is equal to the work done by friction. So what we are going to do now, right, mechanical energy is the sum of all energies. So let's start with the what's it called, final, right? Actually, well, it's negative work of friction, which is why I'm gonna start with initial, right? I'm gonna start with initial. So the speed of the block at the top is 2 meters per second. This indicates that it's not at rest once we let go. So what we're going to do is half times 15 times 2 squared, right? Since mechanical energy is the sum of all energies, we're gonna add mgh. So 15 times 10, which is 150 mg, times 1.6 minus the bottom of the plane, which means there is no gravitational potential energy, so it's just kinetic. 1/2 times 15 times 4 squared, which is 16. Plug this into the calculator. 1/2 times 15 times 2 squared, which is 4, plus 150 times 1.6 minus 1/2 times 15 times 16, which is going to give you 250 joules. Perfect. Solving this question, right? Never mind. I'll be solving 41, like paper 4 version 1, October 2023, question 1, which is this. A particle of mass 1.6 kilograms is projected with a speed of 20 meters per second up a plane line of greatest slope of a smooth plane inclined at alpha to the horizontal, where tan alpha is 3/4. Okay, let's first draw it, right? So we have here, right, and then we have, what's it called? We have the object here where it stands still. So let's draw this vertical. Tan alpha, so like that. If you do tan inverse of 3/4, you'll get the angle, but there's an easier way to do this. Tan is equal to, right, opposite over adjacent. So opposite, right, would be here 3, and here we would have 4, right? And then we can do the Pythagorean theorem to find the hypotenuse in this case, which is 5. Good stuff. So now what we can do here, you could do, look, in the marking scheme, how do we solve this? Kinetic energy, change in kinetic energy is equal to work, right? And the work here will be the force of, here we have normal, here we have W cosine, okay, so W times cosine the angle, which would be 4 over 5. Then here we would have sine, which would be W times 3 over 4, I mean, sorry, 3 over 5. 3 over 5. Perfect. Now we have the kinetic energy. Like we have everything to find this, right? We have the mass, we have the speed, we have everything. So half times m, which is 1.6, times 20 squared is equal to mg, which is the weight. Wait, so yes, my bad, is equal to the work, right? Work. The work in this case, the force we're talking about is weight times 3 over 5. And then work is force times distance. The distance is what we're trying to find. So the force will be 16 times 3 over 5, since g is 10, times distance, which we're trying to find. So again, 1 over 2 times 1.6 times 20 squared is equal to 16 times, this is a 5, not a 6, my handwriting is horrible, times 3 over 5 times x. You'll get 100 over 3, which is 33.3333. Continuous. I'm going to be doing paper 4 version 3, October-November 2022, question 2. A box of mass 5 kilograms is pulled at a constant speed of 1.8 meter per second for 1.5 seconds up a rough plane inclined at an angle of 20 degrees to the horizontal. The box moves along a line of the greatest slope against a frictional force of 40 newtons. The force pulling the box is parallel to the line of the greatest slope. So what we are going to do here, box of mass 5 kilograms is pulled at a constant speed of 1.8 meter per second for 15 seconds up a rough plane inclined at an angle of 20 degrees to the horizontal. The box moves along a line of the greatest slope against a frictional force of 40 newtons. The force pulling the box is parallel to the line of the greatest slope. Find the change in gravitational potential energy. Look, here it's kind of confusing, but here they said 1.8 meter per second for 15 seconds. What's distance? Is equal to, wait, sorry. What's, distance, sorry. Speed, which I'll name v, times time, alright? You can tell by the units, distance is meter, velocity or speed is meter per second, time is in seconds, just multiply, you'll get meters. Simple as that. They want to find the change in gravitational potential energy. So what we're going to do here is just mgh, right? So m is, they gave it 5 times G times H is 15 times 1.8 times what's it called? Times, since, like, let's draw it. Let's say here we have angle 20, but we have the how can I say it? Just do sine 20, right? Since this is the weight and opposite, which is just gonna be the vertical component, which is, come on, the height that we're trying to use. So 50 times 15 times 1.8 times sine 20, which is going to give us 461.727. To find the work done by the pulling force. So the work done by the pulling force in this case is change in gravitational potential energy plus the work done by friction, right? Work done by friction. So they said that the frictional force is 40, right? So the gravitational potential energy was 461.72, so on so forth, plus again force times distance, which was speed times time, which is 1.8 times 15. 8 times 15, which is meant to be giving us, just let me plug it in, 461.72 plus 40 times 1.8 times 15 is 1541, approximately 1541.72. Question of this video, I'm going to be explaining paper 4 version 2 May June 2023 question 1. The question says a particle of mass 1.6 kilograms dropped from height 9 meters above the horizontal ground. The speed of the particle at the instant before hitting the ground is 12 meters per second. Find the work done. So again, simple rule we've done before. Change in mechanical energy is equal to the work done by the resistance force, which is air resistance in this case. So first we're gonna do final, or wait, let me just make sure. Gonna do, yeah, okay, we're gonna do final. We're gonna do initial minus final, since this is the opposite, and if we take the negative to the other side, we're gonna do initial minus final. So let's just do it. MGH, so 1.6 times G, G is always 10, so 16 times 9 minus the final, which is only kinetics, since it's at, like, before the instant before hitting the ground, which is basically at the ground, so gravitational potential energy is equal to 0. So 1/2 times 1.6 times 12 squared, you are going to get 28.8, and that's it for this video. Thank you guys so much for watching this video. We wish you guys the best of luck in all of your exams, and goodbye.